Okay, so first off, in order to understand how we will tile the texture in Zbrush, I want to quickly manually tile a 2D texture in Photoshop, the old school way. This may be really basic if you're an experienced 3D artist, but this is really important to understand as it is roughly the same technique we'll use later in Zbrush. Also, if you usually work in Designer, everything already tiles, so maybe this is something you don't do often. Alright, let's start to create our canvas. So here I want a texture that is 4096 pixel by 4096. Obviously, we want a square texture. This is better in most cases. For the DPI, 72 is fine as we won't print this image. And 8 bits is good in this case. If you work on a height map or an alpha, you'll probably want 16-bit though. Otherwise, if you displace it, you will have a bending effect that is difficult to fix. So now I can click on create. I have my square canvas here. I'll just delete my background quickly and bring my reference. So there it is. Just scale it a little bit now. I think this image makes a good example because this isn't a square image. It also has a good resolution. The brick pattern is organic enough, but not too much, so it still makes a good challenge to tile, and it's a good way to show the techniques I usually use. I also selected this one because there's not a lot of direct lighting and shadows, so it could easily be delighted to create an albedo map later in the process. Now, I want to scale this up and place it in a way that will make it easier to fix the seams later. This means I want to align these stones and the mortar lines as much as I can. Believe me, the more time you spend making sure everything is placed correctly, the easier it will be to hide the seams afterwards. Otherwise, it could quickly become a real headache. Okay, so what I want to do now is to make sure that line here at the top is well aligned with the one at the bottom and starting roughly at the same place. To do so, I can scale the image and also rotate it to make sure the gaps between the stones are similar to what we have in the middle. Alright, I think it's starting to look good now. Well, maybe except for this corner there. Yeah, I will scale it up a little bit more. Just a little bit like that. I think this is good for me. Alright, so now we need to do the same thing for the sides. Even if there are some adjustments to do, we can see that the result is already pretty decent. Overall, the stones are well aligned, especially this one which looks like it's already tiling. Obviously, it's impossible to make it perfect, but it's always a good idea to take a look outside the frame just to see the other options we have. But yeah, in this case, I think I'll keep it like that. Did I just do? Okay, so I think this is pretty good now. When I'm done, I'll just press enter. And now I want to rasterize this layer. And also, as you know, right now, the image continues on the side, so I want to crop it. To do that, I will select everything by pressing Ctrl A. So now I'm selecting the frame there, and I will go under Image, Crop, and it's gonna delete everything outside the frame. So as you can see, if I unselect, now we only have this image. Okay, now to be able to see those seams on each side, what I want to do is to offset this by 0.5. To do so, I will go under Filter, Other, Offset. And since my image is 4096 pixel by 4096, I want to write half of that. It's already written there, but it is 2048 by 2048 to divide it by 0.5. We can now press OK. So we can finally see those ugly seams, but also that there's kind of a gradient in our image caused by the lighting. The fact that the top part of the image is now right next to the bottom part make it easier to notice that this one is way brighter and also more saturated than the other. To fix that, I can select one of the part and match its color and luminance with the one I want to keep. Oh yeah, by the way, it's really important from now on to avoid modifying the borders. The reason is that we know they are already tiled because they were in the center of the image at first. So yeah, I want to fix that gradient but not touch the borders. I'm just gonna go here and just do a little quick use saturation pass. Oh, never mind. Actually, I will select the top part instead since it looks a bit underexposed. So use saturation. I'm just gonna saturate it a little bit more. A little bit too red. Okay, I'll just keep it like that for the colors. Then use a level to adjust the luminance. Oh, this is not masked. Oh, this is way better. I think this is good. Now I'm just gonna merge everything. So if you want to have a new layer on top, this is a Control Alt E. So what I want to do now is to add this new layer on top of the original version and then erase the top and bottom borders to make them tile again. Okay, I'll just hide that quickly. Gonna erase on the top here. I'm doing so. Oh, I'm on the wrong layer. Okay, so now I want to erase just a little bit here to be sure that everything ties correctly. I'm working with the eraser, but doing this with the layer mask would probably be a safer way of doing this. Just reduce the opacity a little bit so everything is now smoother. All right, so now I'm gonna merge again. Also, I'm going to create another layer as I don't want to paint directly on this one. Oh, obviously, don't forget to select the good one. Alright, so the main tool that I use for this kind of stuff is the clone tool. What it does is pretty simple. It works a bit like a paintbrush, but instead of painting a color, it's painting parts of the image you want to copy. To select an area you want as a source, you need to press Alt and then click where you want the information to be copied from. For example, if I go here, I can use parts of the grout that I like and then hide the seams with it. I recommend to keep a 100% opacity. That could otherwise be a bit blurry. But sometimes, like in this case, it can also be useful to reduce it to have a smoother transition. So this way I can make this spot a little bit darker so it feels more natural. This isn't probably the best example for this, but I think you get the idea. I'll probably have the chance to show you better examples of this later. Alright, so the other tool that I use is this one showed on the little thumbnail demo. It's called the spotting brush. What it does is that it uses kind of an AI to automatically fill what you paint. I could, for example, paint the stone and remove it. Well, this isn't perfect, and the clone tool will definitely do a cleaner job, but sometimes it can do the trick. This is more like a lazy option and it works better when used on isolated elements of an image. In this case, at least it can do a good first pass. I think I'm ready to start now. Let's take an overall look just to see where I should start and what will be the hardest parts to do. You can already see that I'll probably start with the top part since the bottom looks a bit more messy and have bigger stones that, well, that will probably be a bigger challenge to fix. I'll probably fast forward the rest of this video since I'll pretty much be using the techniques I just explained. But yeah, I'll stop if I have something to add. Sorry if it can sometimes be a bit chaotic to watch, but yeah, as you can see, I like to often unzoom to keep in mind the big picture and not get lost in the details. Okay, so this one is a bit more tricky as there are three stones intersecting and not very well aligned. To fix this, I can find another one that I could use to recreate the top border. I'm gonna pick this one. Okay, here I have three big bricks that are perfectly aligned. This is something I want to break because I know it will be easy to notice from a far distance, especially if the texture ties multiple times. A good way to fix that would probably be to put a big rock right in the middle of this to break this line there. But yeah, first I'll try to extend this stone to break the line with it, as it is a bit more simple. As you can see, I tried to mix multiple stones together, and I tried to not just copy a whole one. Otherwise, it could be really easy to notice that there's repetition between them. Now that we don't see the seams anymore, I can merge everything together. Again, Ctrl Alt E. And then offset it back to its original position. Again, other offset. We put the same values, 2048 by 2048. Okay. The reason I do this is to verify if there's no seam that appeared there. This could happen if the border is modified by accident. In my case, everything seems fine. So this means that our texture now tiles. And whatever the value we put here, everything will be now seamless. It doesn't mean the work is over, as it is always a good practice to verify in context if there are repetitive elements that are noticeable. Of course, it really depends on how the texture will be used. On smaller surfaces, it can be interesting to have more variations and unique features, but on bigger ones, it is better to have something more uniform. Material blends can also help a lot with that though. At first sight, I can see that there's a spot here with bigger stones. It really breaks the pattern and makes everything feel more organic and interesting visually. But unfortunately, it also makes them really stand out. I'll try to find a good balance. I could try to quickly duplicate it, and maybe it will help to better see the problem. Alright, we can in fact see that there's a lot of noticeable repetition, especially this big rectangle stone there. Long straight lines, like this one, will also be a problem with strong normal. But yeah, let's try to fix the big stone first. So I'll pretty much be using the same techniques that we used before, and I'll try to split the big stone in smaller parts so it blends better with the other stones. Alright, this is already better. Of course I could work a lot more on this, but for the sake of this video I think it will be enough. For comparison, I can duplicate it again and see what we have now. There's already a big difference with what we had before. The splitted parts blend way better with the rest. Well, this was all I had to show for this part of the tutorial. In the next one, we'll switch to Zbrush and set up a new scene to create a tiling sculpt. Alright, we are finally in Zbrush. In this part of the tutorial, we'll see how to sculpt on a plane and make everything tile automatically using one of Zbrush function called wrap mode. But yeah, first off, let's close the lightbox for now and set up the document size. So under the document tab, we can find those sliders to control the resolution. It is a bit low by default and also non-square, which is really important in our case. To be able to change this without being constrained to these proportions between the width and height, I'll have to click on this Pro button first. I can then enter new values here. I personally like 2048 by 2048, but it's up to you. As long as it is square, it should be okay. Just keep in mind that the higher it is, the more unstable ZBrush will be. Click on resize when you're done. Okay, so now we need to create our plane. Of course, you could prepare a plane in another software and import it, But to keep things simple, I'll just use one that can be found directly within ZBrush. So let's reopen the lightbox. Under Tool, open the image plane folder. And now you should see this Z tool called Polyplane. This is the one we will use. Now I will drag it in my viewport and enter the edit mode. If, like me, you get one or more copies of the subtool that you cannot move in the viewport, you can simply press Ctrl N to clear a canvas. I'll just quickly switch to the basic material matcap. Okay, so right now, if I simply select the standard brush and sculpt on the plane, well, if I modify the borders, this isn't a surprise for anyone, it won't tile. Of course, we could sculpt it and make it like this anyway, and use the clone tool technique to fix the seams afterwards, but this would take forever, especially if you consider the fact that there would be multiple maps to match together. Fortunately, there's a way simpler solution to this problem, and it's called wrap mode. Let's see how to set it up. I already customized my UI, so I have a better access to it. But by default, you can find the wrap mode slider under Brush, Curve, oh, and there it is. I'll set this to 1 and we'll see what happens. We can see that the stroke now continues on the other side of the plane. Let's just divide the geometry a couple times so we have a better resolution. Don't forget to toggle off the smooth button as we want to keep the shape unchanged. Yeah, this is better. Okay, now, if like me, you want to have the wrap mode slider directly in your UI, you can go under Preferences, Config, Enable Customize, and then it will let you drag basically any tab in the UI. So let's go back to the wrap mode tab under Brush, Curve. And now, if I press Ctrl Alt and hold the left mouse button, I can drag it anywhere I want. It could be under left bar or there, for example. And if you want to delete something, you can simply drag it on the canvas. Now that I'm done, I can toggle off the Enable Customize button. If you don't want to do this every time you reopen ZBrush, you can save your changes by pressing Store Config. I really recommend you to do that since the wrap mode slider will need to be set to 1 each time you select a new brush. Now if I unzoom enough to see the document entirely and press F, it will frame the plane perfectly within the square document. Make sure the perspective is deactivated though, otherwise it won't work. As you can see, I'm pressing F right now and even without any sculpted details, you can see gaps near the borders. So yeah, be sure it's always turned off. Like I already showed you, if I gently sculpt like that across the plane's borders, it ties perfectly and there's no problem so far. But if I use another brush, like the clay buildup for example, like I said, I need to set the wrap mode to 1 for this brush too. I'll just undo that quickly and start over. Alright, as you can see, sculpting on a thin border like that deforms the mesh a lot. It can become really frustrating to sculpt on a geometry like that, and it will probably create tiling and baking issues later. Also, if I try to press F to frame the plane, it just doesn't work anymore. Fortunately, there's a way to avoid that. First, we need to create a copy of our current plane. This way, we can keep this plane as a low poly mesh and use the new one as a high res mesh, on which we will sculpt all the details. To keep everything clear and organized, let's rename the first plane. Let's say bake plane, for example. Now I can click on duplicate and rename this one sculpt plane. I will then select the new plane and go under deformation, and I will scale it up using the size slider to, let's say, 30. It gives us a safe border to avoid the deformation issue. The new plane is slightly bigger, but since it will be baked on a smaller plane, we only need to sculpt the middle of it. In other words, the part that is aligned with the bake plane. The extra border length we just added is really only there to protect the border. I'll move the plane slightly so they're not overlapping each other. Shouldn't really affect the bake since it will still be close enough, and we could still move it back at the end before exporting it anyway. But yeah, this way it won't be in our way. From now on, it's important that the bake plane remains like that. We will only use it as a reference to help us know what part of the skull plane will be baked or not in our final texture. Okay, let's switch back to the skull plane. Now, maybe you're asking yourself, how can the wrap mold tiling technique can still work if we are working on a bigger plane that will be baked on a smaller one? Well, the wrap mode isn't based on the mesh borders, but on Zbrush unified space. Since we imported that small plane first, Zbrush adjusted its scale within that unified space, which represents around 2 units. We can verify that under the Geometry tab. You can see that in fact, the size is around 2 units for the small plane. If it isn't the case and you're having tiling issues, you can use the Unify button under Deformation to let ZBrush fit your mesh within that unified space. But yeah, be careful with that, as it will resize it. If I go back to the skull plane, because I scaled it up by 30%, we are around 2.6. This is a lot of numbers, I know, but the only important thing to understand is that the wrap mode will basically tile every 2 units, starting from the center, which happens to be exactly the scale of our bake plane. This is why even if I sculpt on the bigger plane, ZBrush is still looking at the unified space as a reference for the tiling. And if we bake it on a small plane, it will fit perfectly within the UV space. For example, I'm sculpting on the bigger plane right now, and my brush stroke seems a bit off. But if I select the bake plane, frame it with F, and switch back to the skull plane, we can see that in reality it ties perfectly. But let's add more geometry so we see it better. And there you go. My brush strokes start exactly at the same place on the other side. And whatever I do, even if I use a bigger brush size and sculpt intensively on the side, the plane is perfectly fine. Nothing is deformed. You could simply sculpt like that and bake this and everything should be fine. But there's another thing we can do to make our plane even better. The geometry is currently evenly distributed on the plane, so there's the same polygon density on the extra borders we add. This means that if I divide the mesh a lot to have a decent resolution in the center of the plane, I'll have a bunch of useless polygons on the sides which could affect performances. A good way to avoid this is to add more loops in the middle to have a higher density compared to the borders. So I went back to the lowest subdivision level and deleted the higher ones. Okay, now let's select the small plane and press F again to frame it. I'll then switch back to the skull plane without moving the camera. And now that we know the area that needs to be denser, while pressing the Ctrl key to activate the masking brush, I'll select the drag rectangle tool instead of the regular brush. I can then use it to mask everything. Of course, this isn't perfect, but now if I unzoom, it is way easier to see what needs to be masked. Now I just need to mask a little bit more, just to be safe. Alright, let's verify quickly if it's masked correctly using the framing trick again. Oh, looks perfect. Okay, now I'll invert the mask by pressing Ctrl I. And if I go back to the Geometry tab and divide my mesh again, with the smoothing button on, it's perfectly fine now as the borders are hidden. It will only divide the unmasked part of the plane. So yeah, this is pretty much it to optimize the plane. Sure, it is a bit more ugly now if we sculpt outside the bake area, but it won't change anything in the final result anyway, so it doesn't really matters. It can be nice to work with the camera framed that way, but you don't have to. Even if it isn't placed like this, it will tile if you have the wrap mode activated. So don't be afraid to move around your object. Personally, I even prefer to zoom in like this so I don't feel constrained by the small frame and I can see better what I'm doing. But it's up to you. You can use wrap mode with most brushes. You can even drag alphas with it enabled. For example, if I select the standard brush, set the stroke to drag rectangle, and let's say this alpha. Never mind, let's say this one instead. Wrap mode to 1. You can see that it works very well. The only issue with this is that if they collide, it can create artifacts. And this is something we obviously want to avoid. But yeah, this is something I use a lot when I want to add details. Alright, so one last thing. Up to now, we have only used wrap mode with a value of 1. So I guess you're maybe wondering what's happening when we set this to another value. Let's set it to 2 so we can see it. So higher values will basically just add more repetitions. This isn't something I use really often because, well, the goal is to create a tiling texture anyway, so I prefer to have a better resolution and tile it one time. But I guess you can maybe use this to create a funky pattern, and why not edit it afterwards without wrap mode activated to create variations or something like that. Really, it's up to you to experiment with this. This is pretty much all I had to show for this part of the tutorial. I'll show you more concrete example of how I use this later, but before that, in the next video, I'll show you how to tile multiple subtools. Okay, so in the last video, I showed you how to use wrap mode to create a tiling sculpt. It works well when you want to work directly on the plane, but it's pretty much limited to that. Creating rubbles, roof tiles, or bricks, for example, wouldn't really be ideal using only this technique. Fortunately, one of Zbrush's strengths is to be able to handle the creation of multiple high-poly meshes that can easily be manipulated to create those type of materials. So why not bake those meshes on the plane to make a tileable material with it? This is what I'm going to show you in this part of the tutorial. I thought creating a pile of coins would be a good example to explain how to do this. So these are some references I gathered. In a production context where you would need to create a treasure or just any pile of object or debris, it could be a good idea to create a tileable material instead of just modeling everything. You can save a lot of time and resources this way. Sure, you could do it procedurally or based on simulation, but doing this kind of material in ZBrush gives you a lot of control and you can easily avoid any interpenetration between the objects. This is something that is harder to do in Designer, for example. When objects are placed by hand, I feel that it's easier to have that sense of depth because they are often placed in a more logical way. Alright, let's start by quickly creating a token so I can show you how to do this. Okay, so I opened Photoshop and decided to create a token design that I'll reuse later as a mask. Since this is a lot of me just trying different things, I'll fast forward this part and comment if needed. So here I'm back in our ZBrush scene and imported the mask created in Photoshop as my alpha by simply clicking on the import button. Then, if I go under the masking tab, I can use the mask by alpha button to create a mask from it on the plane. If I invert it and go under Subtool, I can then use the Extract button to create a new extruded subtool from this mask. Here is the exact same technique, but using a circle shape instead as a mask. This way I can use it as the base shape for a token. I can then adjust how much I want the design to be extruded. For this, I went with something a bit exaggerated compared to reality. When I thought the balance was good, I merged and used Dynamesh to only have one subtool. You can notice that all my brush strokes are repeating multiple times along the mesh. To have the same effect, you can activate the radial symmetry under the Transform tab. Just make sure your mesh is at the center of the scene. Now I'm adding some detail noise with various alphas using drag rectangle. I like to use layers for this, so I can apply them and adjust the intensity in a non-destructive way. Even if it's really subtle in the end, it can help a lot if you want to achieve a realistic look. Now that I'm satisfied with the result, since it will be duplicated a good amount of time, it's important to optimize the poly count. I like to use a combination of Dynamesh at a high resolution to have the clean topology and Decimation Master under Z plugin. The goal is to reduce as much as I can while keeping most details. You can see that there isn't much difference even if there's a lot less polygons. It's important to keep in mind that this token will be a lot smaller in the end. Don't be afraid to iterate with Decimation Master. Once it's pre-processed, you can move the slider again and again and it won't have to recalculate. Okay, good. We now have this little token mesh to work with. Super simple design, but this will be enough to show you how to do this. If you want to reproduce this on your side and push it further, don't hesitate to add more details and imperfections. It really depends on how noticeable these details will be in the end and the time you want to spend on it. So I reuse the same scene we had in the last video with our small plane. I will use it again as a reference to know what will be baked or not. And it's still perfectly filling ZBrush unified space by being 2x2 units. Tiling a mesh like this in ZBrush is very similar to what we did in the Photoshop tiling part. I'll duplicate the token so I can show you a quick example. The same way we did for the Stonewall picture in Photoshop, if I go under the Deformation tab, I can offset this subtool by half the plane's width. Since it's also based on ZBrush unified space, offsetting this by 100 will align the mesh directly on the border. So if I duplicate it again and offset it in the other direction, the second mesh will be starting at the exact same place where the former starts. I will frame the camera on the plane so we can see it better. We can clearly see that if I would be baking these meshes on this plane, there wouldn't be any scene, a bit as if it would be the same mesh continuing on the opposite side. The same trick can be used to create a lot of different materials, from ornament trims to brick walls, or like in our case, a pile of objects. But if we take a look at our references, we can see that we will have a lot of subtools to place by hand, which could take a lot of time. Fortunately, there's a way to speed up the process. To establish a good base to work from, we can use something in Zbrush called nanomesh, which will randomly distribute the tokens over the plane surface. First, I'll want to use the ZModeler brush to assign a token for each of these polygons. This brush is a bit special as it lets you do multiple operations similar to what you can do in more traditional 3D programs such as 3ds Max, Maya or Blender for example. You can notice that a new toolbar appeared with a cube. This is because the ZModeler brush can also insert meshes. This is what we will want to do with our token. To add a new custom mesh inside the brush, I need to right-click on one of the token's face. Be careful, clicking on the edge or a point will give you different options. This menu lets you decide what action the brush will execute when you left-click inside a face. We want to add all the mesh, so let's click on all polygons. And the action we want to do is brush to mesh. Now, we simply have to left-click inside a face, and we should see the mesh appear in the toolbar. Alright, now let's switch back to the plane. Okay, so now to apply the custom mesh, we need to set a new action for the brush. This time, it will be Insert Nanomesh. And again, all polygons. Let's see what happens now if I hold the left mouse button and drag it. Little tokens are applied for each faces. But yeah, this is probably a bit too many for what I want to do. I can maybe try to reduce the amount of polygons using Zero Mesher, which will probably keep the nice topology. Let's try with the half button enabled, maybe. Not bad, but the top left corner is kinda weird. Well, actually we could use the ZModeler brush again to fix this manually instead. This time, I'm going to select delete for the action and single edge loop as the target. Then, I can simply left click on the edge loops I want to delete. I'll start by deleting half of them and we'll see if it's enough. Even though it's already better, I think I'll delete another half just to be sure. Some of the nanomesh parameters will let us control the density also, so it should be good. Now, if I take a look at the nanomesh tab on the right, the sliders aren't grayed out anymore. Sliders on the left will generally apply effects evenly on all meshes, and the ones on the right are affecting the percentage of randomness. Adding some z-offset randomness first helps a lot to add more depth and separate all these tokens. It makes it easier to see the changes applied when moving other sliders afterwards. Other than that, I don't have a specific way of doing this. Honestly, I kinda just play with the sliders until it looks good. Rotating the meshes slightly in all axes can be nice since it will help to catch light at different angles. Just be careful with that and try not to rotate the meshes too much or you may have super harsh normal angles which make us dark shadows that are super easy to notice when tiled multiple times. I like trying out different seeds and alignments to see what gives me the best results. Also, for now I try not to worry too much if there are meshes passing through each other here and there. But yeah, if it's possible, it's always better to avoid it. When I'm finally happy with the result, I can convert these tokens into a subtool by simply going under the Inventory tab and press the Want to Mesh button. In case you would like to use another mesh instead for the nanomesh, you can also replace it from there. Once I clicked on the Want to Mesh button, all the nanomesh parameters are grayed out again since it has been converted to real geometry. This is also why the total poly count is now way higher. 4 million is still fine to bake in Substance, but I try to avoid going over 10 or 12 millions. But it really depends on your PC. Since we use the plane to create our tokens, they're still attached to it. To solve that, because it has a different group ID, while in Move mode, I can hold Ctrl and left click on it to mask it. Now, if I go under Split, I can click on Split Unmask Points to create a new subtool with the tokens. Let's just rename it quickly. Alright, now that we have a good first pass, it's time to adjust things manually. But first, in order to be able to select each token within the same subtool individually, we need to assign a different group ID for each one of them. To see the group assigned to a subtool, I can click on Draw Polyframe here on the right. It also displays the wireframe, which is very dense, so I can deactivate it by clicking on Line inside the Polyframe button. They are currently all displayed with a yellow color. This means they all are in the same polygroup. To assign a unique color to each token, I can go to the Polygroup tab and simply click on Autogroup, which will automatically detect all separate mesh. I also use this a lot to make ID maps, but this is something I'll show you later. So now that they all have different polygroups, I can do the same trick we used for the plane to isolate each token I want to move. So this is Ctrl left click. I can then adjust the gizmo by holding Alt and move it around until I'm satisfied. At this point, I just try to imagine how the tokens will naturally be placed. I try to go from bottom to top as much as I can. It helps to keep the placement logical. Of course, I don't spend too much time on parts that will be hidden, but it still helps sometimes to keep everything consistent and believable. This can be a long process, so I will fast forward the video until the next step. Alright, I placed all the tokens and I'm now satisfied. But this is not over yet, because we still have a big problem. It doesn't tile at all. Let's see how we can achieve this. First, I'm going to duplicate this subtool. As I did earlier in this video, I'll then go under Deformation and move the offset slider to its maximum value. I can now select the original token subtool and do the same thing, except this time in the opposite direction. Then, because we also need to do this for the y-axis, I'll merge these two subtools and reproduce the exact same steps. So this means I need to duplicate this subtool too. The only change is that in order to offset the subtool on the y-axis instead of the x one, I need to click on that little icon here at the top right of the slider. Alright, so same thing again for the other subtool. Okay, now that this is done, you may have noticed that we have a lot more polygons, and it could slow things down a lot. Half of our tokens are out of the bake zone, so they're kinda useless right now. But the good news is that we can delete them without any problem. Let's take a look at this by activating the transparency mode. Everything outside the plane can be deleted. I'll just merge these two subtools together quickly to make things easier. Alright, now I can hold Ctrl and left click on the background to drag a rectangle mask on all the tokens that are out of the bake plane. When it's done, I can go to the split menu under Subtool and click on Split Mask Points. The part I just masked will be separated from the current subtool and a new one will be created from it. I can simply ignore or delete the new one as we don't need it. Alright, let's frame the view to see if it really ties. As you can see, the continuity between the sides is perfect and it works as it should. However, as for a Photoshop example, since we have set everything, the seams are now technically in the middle. This is why there's now overlapping tokens right in the center, and of course we need to fix this. To do so, I'm going to do another pass of manual placement, but this time I need to avoid modifying the borders so it still tiles when I'm done. As you can see, I ended up with too much tokens. I thought it would be a good idea to put it aside and reuse it later to hide a hole. Sometimes, during the process, I like to do a couple of renders just to give me an idea of how it could look with ambient occlusion. Especially with this kind of material where halo is super important to add depth. Once all the final tweaks are done, this iris mesh is now ready to be baked. I use this technique to create a pile of tokens, but it can be used in a lot of ways. Roof ties, rubbles, forest grounds, brick walls can be achieved with basically the same process. This is what I'm going to show you in the next video by creating a material from A to Z, combining all the techniques I showed you. Now that we've learned a bunch of ways to create tiling materials in Zbrush and Photoshop, let's see how we can use these techniques to create a stone wall material from A to Z. I've decided to start from the same picture we tiled in the first part to show you what are the possibilities with this kind of workflow. But first, as for any new project, it's always super important to gather references. These are some good quality images I found. Personally, I use them a lot. Honestly, I probably look more at my PureRef than what I'm actually doing in ZBrush. In my opinion, it's also very important to understand how things are built, and sometimes pictures are just not enough. And this is why I like to watch videos and read a bit about the subject I'm working on. For example, a stone wall should look like the stones are stacked in a logical way, and not just inserted into the ground randomly. The masons usually stack stones rows by rows and then add a layer of mortar between them. The joints are then cleaned with a trowel or a brush, and over the course of time, the mortar will disaggregate faster than the stone, which will create deeper joints. The stones will also start to fall and break, creating this kind of a messy look. In this particular case, these walls seem to be made of sedimentary stones, such as sandstones or limestones. They're basically layers of compacted sand and seashells, and this is why we start to see these layers appear when they break. This is something I need to keep in mind when I'll sculpt damaged parts. Knowing these facts will not only let you create a credible and grounded material, but you'll also be able to tell a story through it. Since I'll be using this diffuse as much as I can, I'll start by creating a mask, a bit like I did for the tokens. I simply use the lasso or any other selection tool to select each stones and then fill them using the bucket tool. Alright, when all the stones are masked, it's time to offset everything to make sure it's tiling. Now that the seams are fixed, I can fill the background with black and export this. I made sure to use another layer, just in case I need to do some tweaks later. Back in ZBrush, I can import this mask in the alpha menu, and then extract the stones like we did before for the tokens details. At this point, I realized that the space between some of the stones was not large enough, so they merged together when I extruded them. I decided to fix this by going back to the masking step and painting these gaps manually to make them larger. After I made sure all the stones were well splitted, I assigned a different group to each one of them so I can easily isolate each stone with a mask using the Ctrl left click shortcut. Alright, so here's a new trick I haven't showed yet. This is especially useful when you want to create a sculpt based on an already existing diffuse, like in this case. We can actually project this diffuse on the subtool. In order to do so, let's go under the Draw tab and activate this floor button here. Alright, nothing really happens yet. But if I go under Front Back and then click on Map 1 to browse my diffuse, it will add it to the background. Obviously, I need to scale this down. Let's set the tiling to 2 and the grid size to 1. Oh, by the way, if you have annoying green lines appearing, you can hide them by clicking on this P-line button here. We now have this image in the background, but still not really useful, right? We'll need to go back to the Draw menu and move the Project on Mesh slider completely to the right. And you'll get this cool projection effect on your mesh. This is super useful when you want to know where to sculpt some of the details. Of course, you can add the slider to your UI and control the opacity from there. But since it uses the floor, I like to simply click on Shift-P to hide it and unhide it. But if you can't remember the shortcut, there's also a floor button in the right side toolbar. Alright, I think I'm now ready to sculpt. To make things easier, I first separated all the stones to different subtools using the Split by Group button. I then used the background image as a reference to block out the big shapes. Clay tubes and clay buildup are probably the brushes I use the most for that. I then use Trim Smooth Border and other trim brushes when I'm ready to sculpt more detailed shapes. They are probably the best brushes to sculpt rock surfaces. If you're not familiar with these, I recommend you to try them and take a look at the brush folder in the lightbox. There are plenty of brushes there that are not in the brush tab by default. Using a combination of masks and the move brush is also a nice way to move big shapes without having to resculpt everything. The goal for now is to focus on the big and medium shapes and not waste too much time on smaller details. Those will be done later in a more efficient way. The stone I'm sculpting right now needs to continue on the other side if I want the bake to tie properly. To make sure it works, I can duplicate this part and offset it on the other side like we did for the coins. I can then merge the two subtools together, dynamesh everything to fill the gap between the two parts, and complete what's left to sculpt. When it's done, I can duplicate this one and replace the stone on the other side with it. Obviously, sculpting all the stones one by one is a long process, but it's really worth it if you're aiming for a material as realistic as you can without having scanned data. If you're under short time constraints though, this isn't maybe the best way to go. A good alternative would be to sculpt some stones and build your wall by duplicating and rotating them. This way, you'll be able to create an entire wall with only a few stones. If you place them well, it won't be too noticeable that they are all the same. The downside of reusing stones is that they'll have to be more generic, and the albedo will have to be created from scratch instead of the technique I'll use later in this example. Once all the stones are done, I can start to sculpt the mortar. In order to do so, I'll use the sculpt plane. This will allow me to activate the wrap mode for all my brushes and not worry too much about the tiling. First thing I want to do before sculpting anything is to set a good depth for my plane. You can see that the projection still works, but I'll add something else to help me even more. If I create a new texture by clicking on the New Texture button under Texture Map, and then go under Displacement, I can apply an height map based on the plane's UVs. You could import any ground height map like a scan or one created in Designer, but in this case I extracted the details from the image using a high-pass filter. I'll show you how to create one in a minute, but for now, let's use one I already created. If I increase the intensity using the slider, some details start to appear. I can then click on this button to apply the changes. But that's not really what I want to do, because it's really flat right now. What's nice with this is that I can let the preview without clicking on apply and still sculpt. The only problem you may have noticed is that it's not really placed correctly at the moment. The thing is that we only want to sculpt the middle of the mesh, but the texture is still applied according to the UVs, which are including the extra border. I could fix this by scaling the UVs, but I'll show you how to create the map and at the same time another way to avoid this problem. The map I want to create for this isn't really a real light map, as it will be based on the diffuse light information. But even if it's not technically physically accurate, since I'll be sculpting the big and medium shapes in Zbrush anyway, extracting the fine details with this technique is a fast way to achieve what I want without affecting the end result. First, I'll need to convert this to black and white. Then I can merge the layers and go under Filter, Other, Height Pass to apply the effect and select the radius. With a lower radius, the values will be more compressed but can become a bit noisy. Let's set this to around 10. Good. Now that we have our detail map, we still need to adapt it to the center of the plane. Okay, so the size slider in the deformation tab in Zbrush goes from -100 to 100. It means we have a range of 200 units. And we previously scaled the sculpt plane by 30 units. This means it represents 30 units over 200. But in Photoshop, the transformation is expressed in percentage, so it's equivalent to 15%. And since we want to scale it down, it means we need to set this to 85% of its actual scale. Alright, let's do this. So 85% for both axes. Okay, now I can simply copy-paste this layer to fill the sides. This way we can be sure it will be tiling. When it's done, I can simply save it and import it in Zbrush. I really like to do this as it helps me to spot the main features while looking at my references. And since it's just a preview, I can sculpt without destroying all the details. For this part, I mainly used a combination of clay buildup, trim smooth border, and rake for the brushes. Sculpting height variations around the stones and adding some parts where the ground goes over them will help to make everything more believable and grounded. It will also be more interesting to see how the light reacts with the surface, making it easier to read the values. Don't be afraid to modify the stone's depth when you need to. Again, the wall will just look more natural. Alright, I'm now done sculpting the mortar. Let's apply the detail map so it becomes real geometry. Just to make sure everything is fine, I can add more geometry and a layer so I can control the intensity. Let's click on Apply. There isn't much visible changes compared to the preview, but it's now part of the mesh. By hiding the layer, we can see the difference. If I would like to add more detail layers, I could easily import other maps the same way. Of course, the details could be added in Designer afterward, and while it could give you more control over the intensity, baked information looks a bit better in general, at least in my opinion. That's also true for the stones, and that's why I would like to add finer details on them too. Personally, I like to add these details by dragging alphas, since it's the fast way of doing it, while still keeping control over what I'm doing. Again, I use layers a lot for this part. Like in this case, where I apply a strong effect at first, but reduce the intensity afterward for more control. Of course, don't forget to duplicate all the stones continuing on the other side. Even soft-looking stones have small grains if you look closely, and this is why they are generally matte. All roughness information that is big enough to be seen in the normal should be done this way. Roughness and gloss maps should only be used for microsurface details, or in other words, everything smaller than a pixel. So if I don't want to end up with something looking like a rough plastic surface, I must add some grains one way or another. If you like texturing in Substance Painter, having this amount of details will have a huge impact on the result you'll get using smart masks and smart materials. The reason is your baked maps will be way more detailed. I use different matte cap depending on what I need to see, but the basic material one is the most accurate to evaluate how intense the details are. When you're done sculpting and you're sure you won't add more details, you can decimate your mesh so you don't have too much polygons. Alright, now that I'm satisfied with my sculpt, it's now time to export it in order to bake it and create all the maps that I need. But before that, even if I decimated the mesh, I still have too much polygons and Designer may crash during the bake. So this is a good opportunity to show you another way to optimize the mesh even more. A bit like I did for the tokens, I'm going to delete the parts I don't need. So first thing I'm going to do is to merge everything together. Then I'll verify if the groups are still tiling. Since it's not tiling anymore, I'll need to fix this. Obviously, auto group won't work in this case, so I'll press the merge similar group button, which assigns the same group to the parts with the same amount of polygons. And now it should type properly. I can now mask everything outside the bake area. Activating the ghost mode can be useful for that. I can then click on split masked points and hide the new subtool. And we now have an optimized mesh with a decent polygon for the bake. Which means I can finally export my mesh by clicking on the export button under the tool tab. We will also need to export the bake plane. If, like me, you use the plane directly from Zbrush, you may need to flip the UVs vertically. In order to do so, just go to UV map under the tool tab and click on Flip V. And as we did for the sculpt, we can then simply click on Export. In the next part, I'll show you how to bake in Designer. So we are finally ready to bake. I chose to show you how to do this in Designer for its versatility, but any other baker could do the job. Painter, for example, if you plan on also using the software to create your maps. The only downside is that it won't be possible to create an height map in Painter. Marmoset Toolbag is also a very good option, especially with the cage system, which allows you to see it in real time and correct the skew easily. Also, Xnormal, even if generally slower, can handle more polygons and is free. But let's see how we can do this in Designer. First, let's create a new project. I'll choose the basic PBR template, but you can use the one you prefer. Alright, now in order to bake, we need to import our low poly mesh, which is in our case the bake plane. I can simply drag and drop it there. Now, to open the Bake menu, I can right-click on it and select Bake Model Information. If you're not familiar with baking Iris models, The goal is basically to convert the high-res mesh in various bitmaps so we can apply them on a low-res mesh to create the material. It's now time to import the high-res mesh. If you exported it in multiple parts, it's also possible to project them all at the same time if you want. In my case, I'll just need to import this one. Here I can choose the texture size, let's say 4096 by 4096, and then the format. But let's keep PNG, which is the one by default. We can also change the amount of subsamples. Be careful with this one as it will increase baking time a lot. Alright, it's now time to choose the maps I want to bake, by clicking on this Add Baker button here. In my case, I'll need an ambient occlusion map, curvature, height, normal, and a color map for the ID map. Be sure to select the BiMesh ones or nothing will appear. On the right, you can see parameters for each one of them, but default values are generally good. The only one I'm going to change is the color map. I'll need to set this to polygroup and random to project color for each polygroups I add in Zbrush. Let's now choose a folder for the export and a name for the maps. The $sign in the name right now means it's a variable. Using the mesh's name doesn't really make sense in my case, so I'll change this for Stonewall. Alright. Okay, so here's where I need to set the projection distance. The goal is to set this high enough so all the high-res mesh is projected on the plane, but at the same time, we don't want the value to be too high. A good way to test this is to reduce the resolution to have a faster bake time and try different values until we find the good spot. I also like to reorder the bakers in a way that the fastest ones are computed first. This way, I can stop it faster if I see an error. At this point, this is important to save the baking setup in case it crashes. For example, if your eyepoly is too heavy. Don't forget to also save your project. Okay, now let's click on Start Render. As you can see, we have large black areas in our bake, which means the high-res mesh is clipping. I'll try with higher values. Well, this is not enough yet, so let's do it again with an higher value. Alright, I think it's good now. I can now increase the resolution for the final bake. If you want to take a look at your maps, you can use the drop-down menu here. Well, I think everything looks good. Let's take a look at the ID map. This will be very useful to create different masks using color selections. And this is also something you can use in Painter. Once you close the baking menu, all your bake maps will now be displayed here in the Explorer. You can also find them in the folder you specified. From there, you can simply drag and drop them in your graph. Sure, some of these maps could also be created using nodes in Designer, but the results can sometimes be a bit different. To see what I mean by that, let's compare our baked curvature map to the curvature nodes. So here's the baked one, and now the regular curvature node. As you can see, the baked one is slightly smoother, and the one from the node is sharper. And now, if we compare with the curvature smooth, it's completely different, similar to what we would get by adding a blur node after the curvature one. Overall, I think I get better results using the baked one as there are more subtle variations, but it really depends on the situation. At this point, it's always a good idea to verify if everything ties correctly by pressing the spacebar in the 2D view. Look closely as sometimes errors can be hard to see. Everything was fine in my case, so I can now plug all the maps and see the result. So this is what we get in the 3D view. As we don't have a base color yet, I plugged the curvature map for now just to give an idea. Most of our maps already look good, but we'll need to create a roughness map and an albedo. Let's try with the diffuse just for fun. So as you probably remember, this is the image we used to create our layout. But this is clearly not an albedo as there is a lot of light information. The result isn't that horrible, but this is clearly not PBR as there are way too much shadows and highlights, and it wouldn't make sense depending on where the lights come from in a game. I could create the albedo from scratch using smart materials in Painter or directly in Designer, but I would like to show you another way as we already have a diffuse map. I could create a delighted version of it. Let's import an albedo I already created this way so we can see the difference. At first glance, it looks a bit flat because there is less light information and we're used to it. But now, it should fit any lighting scenario. If I activate the background and make it visible, you'll see that it looks a bit more like it belongs there compared to the diffuse which feels out of place. But of course, I can tweak it even more in Designer to enhance the result. But first, let's see how I created the albedo. There are automatized ways of delighting an image. AI is becoming better and better at doing this, but honestly, I've never seen a result as convincing as something made by hand. And this is why I'm going to do it this way. This can be a long process for highly detailed images containing a lot of light information like this one, but most of the time it is quite simple to do. I recommend using scan data as a reference and PBR charts while doing this though. Alright, so I first started by clamping my luminance values using a level. Since the average luminosity of coal, which is one of the darkest materials, is around 50, and 219 would be the luminosity of something very white, like white paint or white paper, nothing should go past these values. And if I let this level at the top of my layers, I won't have to think about it. I then adjusted the midtones a little. In some cases, I try to set the blending mode of the level to luminosity. It helps to preserve the colors. After that, I did a bunch of adjustments just to have decent midtones. And since our perceptions are often biased, I picked colors where I thought the lighting was more neutral and compared it with PBR charts. I then used the dodge tool on the darkest parts to make them lighter and the burn tool to darken the highlights. Some parts of the image were too dark and no more information was visible there. In these cases, I used the clone tool to recreate them. As you may have noticed, I also imported the AO map in another layer in Multiply to be able to see where the stone stops. It's important to make the difference between dark spots on the stones and actual shadows. We don't want to remove these dark areas. So here's the final result with the highlights and the shadows removed. Of course, I made sure everything was still tiling correctly and did some funny tweaks on top of it afterward. It now looks a bit flat because, well, our brain can understand volumes without lights, but adding the baked AO on top of it as a preview already gives us a good idea of the final result. Now, let's see how I use this map and the other one I baked in Designer. Alright, so here's my graph. Nothing really complex as you can see. I simply plugged and tweaked the maps a little bit, except maybe for this part here where I added some height information. Let's zoom in a little bit so we can see better. Alright, so the border looked a bit smooth, so I decided to add more detail noise. I didn't want something too complicated, so I just blended a black and white spot noise with a dark 2 noise. and reduce the contrast a little with the level. I then mixed it with my baked normal using a normal combine node. But to avoid having the effect all over the material and not just on the grout, I needed to create a mask. So I used the ID map with the color masks node and selected the blue color in the background to isolate the grout. I then blurred it a little to have a smoother transition. After doing this, I felt the stones were lacking a bit of detail too, especially the smart cracks in the image that were not present in the normal. This is why I tried to reuse the diffuse map and extracted the details with the high pass node. I then turned it into a normal map. And as I did for the grout, I mixed it with my baked normal and reused the same mask but inverted it. I then needed to create an interesting roughness map. I started by the baked curvature and isolated the concave and convex surfaces to make them rougher. Then, with the facing normal node, I isolated the blue channel of the normal and increased the contrast. This way, I can make every surfaces that are perpendicular to the plane a little bit rougher, so the flat surfaces stand out more when the light hits the surface with a good incidence angle. It really helps to read the volumes. So I blended everything together. And to simulate some dirt, I added grunge on top and multiplied the AO. Finally, I adjusted the overall intensity with the level. Oh, and you may have noticed, but it's inverted because I'm used to work with gloss maps. So there's an invert grayscale node in the end to convert it into a roughness map instead. So that's it for the roughness. For the height, I simply plugged the baked map as it already looked good. And finally, for the albedo, I first blended the delighted map with the baked curvature in soft light mode. This is really subtle, but it gives a slightly sharper look. I also added a blend with the baked Teo map, but the opacity is set to 0 as I will keep it separated. But sometimes it can be useful to add a little ambient occlusion directly in your albedo. It really depends on the engine and how the maps are packed. Don't add too much though if you want it to remain PBR compliant. Alright, so this is the end of the tutorial. I really hope you enjoyed it and that it helped you. And who knows, maybe even inspired you to try new workflows. If it's the case or you simply want to exchange about the subject, don't hesitate to send me a message on ArtStation. I'll leave you with some final renders I created in Marmoset Toolbag. Thank you.